Solidity is the programming language of Ethereum. It's the most widely used coding language by blockchain developers. It allows us to deploy code on a permissionless peer-to-peer network which acts as a global computer. In this tutorial, we'll be going through the basics of writing, testing and deploying your very first smart contract. My name is James Puccini, and on this channel I create content about blockchain development and decentralized finance. Please hit the like button for YouTube algorithm and subscribe for updates. So we're going to need some tools here. First of all, we're going to need a copy of MetaMask. This is available for metamask.io, and this is a browser wallet. Once we've got this installed, we're going to want to switch it to a test network. So as standard, it comes under Ethereum mainnet. We just want to switch that over to the Gorelli testnet network. We can then Google Gorelli Faucet and we can get some free ETH to play with. So this will give us some free funds to use on the testnet. Those funds aren't worth anything, it's just used for testing purposes. But this is a remote external network, almost a copy of the Ethereum blockchain. The next thing we're going to need to use is Remix. This is an editor, compiler and deployment framework built within a web browser for Ethereum and Solidity coding. So we can go to remix.ethereum.org and we'll get something like this. This is quite zoomed in, yours might look a little bit different, but we can create a new workspace, and if we go to contracts, we can create a new file. Let's go ahead and create a file. We're going to call this hello world.sol. I'm going to copy and paste a simple hello world script. We'll go through this in a sec. Into IDE. So we've got the first line is a license identifier. We're using the MIT license here. You can use whatever you're comfortable with. Then we're defining the version of Solidity. So we're saying that to compile this contract, you need to have SOLC version 0.8 or higher. That's fine. Then we're giving our contract a name. This contract's called Hello World, and we're setting a global string. It's a public variable, and the string variable name is greeting, and the value is Hello World. And that's all we really need to do. Compile this, send it to the blockchain. We'll have a public getter function where we can call that data and see that the greeting equals Hello World. In this contract, I've also added a setGreeting function. This takes a string as an input, and it basically updates that greeting value to whatever we give it. The final thing to note is that we're using call data here. I won't worry too much about that at this stage, but just bear in mind that to read data off the blockchain is free, but to write data to the blockchain, there's always a transaction fee. And things like Ethereum storing and modifying data can get quite expensive. So now we've got our Hello World contract. Let's go ahead and compile this. Compile Hello World. We're going to this next tab here. That's compiled fine, no errors. And if we go to deploy, we've got a few options. We can deploy to our local environment. Let's do that now. So we don't need to use MetaMask for this. It's basically deploying it to a virtual machine running within the browser. If we scroll down, we can expand, deploy contracts, we can expand this, and we can see the greeting here, Hello World. And let's try deploying it via Injected Web 3. Injected Web 3 is going to allow us to connect MetaMask and deploy this to a remote network. That remote network could be the Ethereum mainnet. Obviously, there'll be a real charge for that. We're going to use the Gorelli testnet so that it's actually free. We just need some Gorelli test ETH to deploy the contract. So we're going to confirm that transaction in MetaMask. Because this is a real testnet, it's going to take 15-20 seconds to go through. You'll get a little confirmed transaction. And if we scroll down, we've got this now on the remote network. So we can copy this code. And if we go to view on Etherscan, let's paste in that contract address. It hasn't actually updated yet, so we'll come back to that. But let's try getting the greeting, Hello World, and we can update that to Hi, James, set greeting. Again, we'll have to pay for a transaction fee here because we're modifying the data that is stored on chain. We're effectively changing the state of the Ethereum mainnet, or this Ethereum testnet in this case. So we're going to confirm that transaction. That's been confirmed. Let's check the greeting has changed. And we can see there that the data has changed. The data that is stored within the peer-to-peer network has changed. The state of the network has changed. If we go back to Etherscan, let's press F5 to refresh this page. We see we've now got the contract event, there's some contract information, and we can see the transactions going into that. And if we refresh that again, we can see that the set greeting transaction has been recorded as well. Okay, now let's go through some more examples and learn a little bit about Solidity code. So one of the things that I find most interesting about Solidity is the ability to have transfers and transfer funds around and have a kind of programmable money. So let's look at how this would work. So here we've created a smart contract called bank. All these examples are in the blog post, by the way. And we've got a constructor argument here. So we first of all defining a global variable as owner. And then in the constructor function, which will only run once when the contract is first deployed, we set the owner value to the address of the message.sender. This is the person that deployed the contract, so they effectively own the contract. And later on, we'll see that they have special privileges. We then have a receive function, and this enables us to send ETH to the contract. The contract is able to receive and hold ETH within that address. We have a check balance function, and this simply returns the balance of the address, so it shows how much ETH the contract is currently holding. This is a public view, which means that it doesn't cost anything, it doesn't change the state of the blockchain, it's just providing data from the chain. You can also see here that we've returned a uint256. This is an unsigned integer, and Solidity is a strongly typed language, so you have to define the types. You have to define the type of the data, and once you set a variable to a specific type of data, you can't change that. So you can't, like in JavaScript, you can set a variable as false or a Boolean, and then change it to a string later. You can't do that, it will produce an error in Solidity. The final function we have is the withdraw function, and this is a require statement. This asserts that message.sender, which is the person that carries out the transaction at a later date, is equal to the owner, that is equal to the person that first deployed the contract. Otherwise you get an error saying you cannot withdraw funds. So this ensures that only the owner of the contract can withdraw the funds held within the contract. We also have an unsigned integer for a contract balance, and that is just simply the balance of the contract again. And then we simply transfer the funds back from the contract to the owner using this transfer function. It's actually more secure ways of doing this, but this is left in for simplicity. We can again go ahead and compile this. Let's deploy it locally. Here we've got a contract, so we can check the balance is 0. To send some ETH, we can use a test account. You can see we've got 99.999 ETH in our balance. Let's send 1 to the contract. Do this, we just click transact. Let's check the balance again. You notice it's returning the Y value. This includes the 18 decimals, which is quite common both with ETH, the native coin, and also with ERC20 token contracts. Most of them use 18 decimals as well. Now let's try doing a withdrawal. Check the balance again, gone back to 0, and our balance has been secured back up here. Let's look at another example. So a simple ERC20 token contract. So this is kind of like the governance tokens that a lot of people use. It's very similar for NFTs as well. And we're going to use a standard library. I'm using the Open Zeppelin library. These are excellent and widely used throughout the industry. And this kind of gives us all the background functions we need to create our own token. So all we're going to do then is call our contract myToken. Through our constructor argument, which only runs once when it's deployed, we're actually going to pass arguments to the ERC20 contract constructor argument. We're going to give the token a name, and we're going to call it MTKN. That's the kind of the ticker symbol for the token. And then as part of that constructor argument, we're going to mint 100 tokens plus the 18 decimals to message.sender. This is the person that deployed the contract. So they're essentially going to end up with all the tokens in their account balance, and they can do with them what they please afterwards. Okay, so let's deploy this contract. We need to change it here to myToken. As standard, it's kind of coming up with the ERC20 token. We don't want to deploy that on its own. Let's deploy. Scroll down to myToken. You can see we've got a lot more functions here that we haven't written, and these are all included as part of the ERC20 library, which is inherited by our myToken contract. Let's copy the balance. Let's copy the account of the deployer and check his balance off to make sure he's got all the tokens. And there you can see Those are the amount of tokens, including 18 decimals, that he holds in his account. We can then transfer them, approve them for spend, all the normal kind of stuff you can do within an ERC20 token contract. The final thing I want to show you is how we can combine different contracts, both the contracts that we've written and third-party contracts, to kind of build on what they call like the Lego bricks of Solidity or Lego bricks of DeFi. We can use other people's code and our own code and mishmash that up into useful contracts that are doing different things with third-party services. So let's have a look at this. This is a fairly simple example, but it's more complex than the previous examples. So you've already seen a lot of this code. This is basically combining the bank contract and the MyToken contract. So we're defining a ERC20 MyToken, and then we've got a second contract, which is token sale. So instead of, whereas the bank contract took in ETH and it just held that within the contract vault, we're actually going to be distributing out our MyToken tokens to users who send us ETH. So it's kind of like a token sale type contract where people can buy the MyToken. So we're defining an owner account again and a MyToken public variable. And then within the constructor function, we're going to set owner to message.sender, as we've seen before. But then we're going to deploy the MyToken contract from within Solidity. So this is going to create a new version of the MyToken on the network. And the owner of that function is not going to be the deployer, but it's going to be the contract itself. So essentially, this contract is going to hold all the MyTokens in its wallet because the mint function has minted those tokens, and the owner is the contract itself rather than the user who deployed it. Then we've got some functions here. We've got the buy tokens function. This is external and payable, which means that it can accept ETH. So you can execute this function and send ETH at the same time. And that's going to require that the message.value, which is the amount of ETH sent, is greater than 0. And then we're going to check that the balance of this address, so the contract address, has enough of the MyTokens to fulfill that request. And then we're going to basically send out the same amount of tokens as they sent in ETH. So if they sent 1 ETH, we're going to send out 1 MyToken, and both have the 18 decimals included as well. Fairly straightforward, probably overly simplified and not very secure, so don't use this in production. We also have a check balance function, which just returns the ETH. We saw that in the bank contract already. And then we have a withdraw function, and this is exactly the same as the bank contract as well, where just the owner is available to withdraw the ETH from the sold MyTokens. So let's go ahead and deploy this and see if it works, which it does. It compiles fine, so let's go ahead and try this out. Now I don't want to deploy MyToken, I want to deploy the token sale contract. Let's go ahead and do that. And let's try and buy some tokens. So we're going to have to put 1 ETH in here. And then if we go down and click buy tokens, you see that's gone through, and there should be the tokens in there. And we've also got a contract address here. So if we go to MyToken and then @address, let's load that up. And we should be able to see, if we copy this address, that we've actually purchased some of the MyTokens into our user account. And there they are. So we've purchased 1 MyToken, and the other 99 should be held by the contract address. If we paste that in here, you can see you've got the 99 tokens left, which are still available to be purchased with the 18 decimal places. So this is an overly simplified example of how you can combine different contracts to build on top of what others have built in the previously. And it doesn't have to be a token contract. You could use Uniswap, for example, which is an automated market maker for swapping tokens, or borrowing and lending platforms such as Aave, to do different and interesting things to build out your products. No Solidity talk would be complete without talking about testing. As blockchain developers, we tend to spend more time testing our contracts than we do writing them. Here I'm installing a JavaScript framework known as Hardhat to start writing some unit tests for our contracts. We're going to do npm install -save hardhat and then npx hardhat init. We're going to confirm that we want to create a simple project. This will give us a nice directory structure, and we can go in and rename this greeter.sol file hello world.sol. We're then going to paste in the hello world contract that we were using earlier and save that using VS Code. Now if we open up sampletest.js, which is our unit test suite, we can see we've got this greeter function. We're going to change this to hello world, which is the name of our contract. And then I'm going to give this instance a variable of HW. This is going to be the instance of our contract which we're going to interact with. So we can call functions like hw.greet, and that will return the string, and hw.setGreeting, that will set the string. It will update the data stored on chain. Fortunately, this test suite was written for a contract which is almost identical to the one we were using. We just need to change some of these values around. We need hello world to match exactly. Just that exclamation mark on the end would cause the test to fail because the strings wouldn't match if we left that as it was. We also don't need a constructor argument here. And everything else looks pretty good. Now let's run this with npx hardhat test. And we're getting some errors here because it's requiring different modules. So we can install these modules with npm install -save, and then just paste the module name in. Now if we run that again, we should get a completed test. So you can see we've got one unit test in this test suite for the hello world contract. It should return a new greeting once it's changed, and that's passing. Obviously we can add more complexities here. We can add more unit tests. We can do things like sending transactions between different users. There's a lot further you can go with this to test and make your contracts more robust before you deploy them to the mainnet. So it's great that we can deploy a smart contract and we can use that and interact with it via Remix or other Ethereum clients. What about if we want to interact with it via a web page, for example, or some kind of decentralized application? We want to kind of have it more of a user-friendly environment for people to execute functions on their own. So here's an example of a simple web page. We've got HTML, we've got some buttons here, we've got the greeting itself. This is given an ID of my greeting. Then we've got a read button, a write button, and say text input for new greeting. This is standard HTML code. We're importing the ethers library. This is a kind of Web3 library used for connecting to an RPC node and then interacting with smart contracts. We then start our own JavaScript and we're just defining the provider. This will be our Web3 provider, which will we will get that via MetaMask. So we'll be connecting MetaMask to this front end, and that will provide us with the link to the RPC node, which is actually a peer on the decentralized network. We have a signer and a HW variable. The signer is going to be the user account, and the HW variable is actually the hello world contract. We have an ABI here. An ABI is a way for us to explain how the contract works, how to kind of package data to send and receive from the contract. It's basically a very similar layout to how we write our functions in Solidity. If you don't have this available, you can normally copy it from Etherscan, or you can go into compile, and somewhere there is a way to copy the ABI here. You might need to format it for JavaScript once you've done that. Once we've got our ABI in place, we have the contract address. I think I've redeployed this, so I'm going to copy this from Remix. So if we go down to deploy contracts, we can copy that. This is again in the Gorelli testnet, so we need to make sure that MetaMask is set to Gorelli. We then got connect function, which sets up the signer and the hello world contract, and it will change the connected button to connected. We've got the read button, which simply goes and fetches the information from the blockchain and writes it to that my greeting h1 tag. And then we've got a write button, which takes the input from the new greeting text input, and it will actually send that to the chain. That will alter this state. So we'll need to sign a transaction in MetaMask to do that. And then once that's been done, we can update the read function again, and we can get that data back. So let's see how this works. A rather beautiful web page. I'm hosting this on WAMP, Windows, Apache, MySQL, PHP. Any web host will do. You can host it remotely if you want to as well. Let's connect it up. We're already connected, I've already signed in. You might have to confirm that on MetaMask if you're doing it for the first time. Then let's read from the smart contract, which is coming up as hello world as default. To update the state, we have to sign a transaction. That's going to cost us a little bit of ETH. Obviously, this is testnet ETH. We're not doing this on the mainnet. Now, if we read the function now, it will still say hello world because the state hasn't been updated. We have to wait for that transaction to go through before we can read the state again. There you go, that's just been confirmed. And we've got the updated state. So the smart contract has actually been changed and it's now storing the data that we've updated. Obviously a very simple version of how you can store data on chain and manipulate it as you see fit for your product's requirements. I hope you found the Solidity for Beginners tutorial useful. If you're interested in learning more about Solidity and maybe looking at some more kind of intermediate tutorials, there's some more on my channel and my blog post, which is linked to in the description. Please hit the like button for YouTube algorithm, consider subscribing, and thank you for watching.